Okay, hi class. So assalamualaikum and good day everyone. So now we already enter week 12. Okay, week 12. Right. So for this week we will enter the new chapter, which is chapter 5. Okay, and this chapter 5 will be the last chapter. Okay, so chapter 5 is about partial differential equation, or in short, okay, after this I will use PDE, okay, partial differential equation. So basically you already have an idea or about PDE because I already teach it this, but it's just little bit lah. We touch on the what we call the definition of PDE in chapter 1. Okay, if you still remember, in chapter 1 you need to identify the ODE and also PDE, is it? So now this chapter is only about PDE. Okay, it's only about PDE. So you need to know the definition. Okay, of course the definition. So I think I don't want to teach, or I don't want to repeat again here, because you may write or you may watch again the video, what's the meaning of PDE. And also, okay, I just write down the tree diagram, the content for this chapter. So you need to know the definition. Okay, after that, okay, you will also need to know the order. What's the mean by order? What's mean by the linearity? And also the third one is to check whether the equation is homogeneous or non-homogeneous. So for order, what's mean by order, what's mean by linearity, so you can refer back to the chapter 1. Okay, I don't want to repeat again here. Basically it's the same like chapter 1. Okay, so now, so the new topic lah for you in this chapter is the classification. Okay, the classification of the PDE. Okay, so this is the topics that I will cover in this video. And then solving. Okay, we learn how to solve. Okay, how to solve the PDE lah. Okay, right. So class, basically chapter 2, chapter 3, chapter 4 tak, chapter 2 and Laplace. Actually that one will be the ODE. Okay, that will be the ODE. We solve the ordinary differential equation for chapter 2 and chapter 3. So then chapter 4, Fourier series, we will implement chapter 4 in this chapter. Okay, so chapter 4 is a part of this chapter actually. So chapter 4, basically what I can say that chapter 4 Fourier series, as presented in the previous chapter, it becomes a very important part when we want to solve PDE in this chapter. Alright, so please, if you are still struggle in Fourier series, so make sure you practice more, or do a lot of exercise on Fourier series, because there will be important parts to solve PDE here. Okay, but class, for this solving PDE, we have two approach. We call it as we have an analytical approach, and we also have a numerical approach. So analytical approach, they have one method that we will use, which is a separation of variable method. Okay, the name that we will use here is separation of variable method. And then for numerical, later on I will explain later on lah. Okay, because for this week, this is what I will cover. Okay, definition or this order, linearity, so you may study by yourself by just referring to the previous chapter or previous slide or previous video. And for this week, I will cover the classification and also the separation of variable method. Okay, so this is our objective for this week. So without further ado, I will start with the classification of PDE. Okay, the classification of PDE. So first, you need to know the equation or the general equation for this for our syllabus. Okay, we will use the second order linear PDE. Okay class, so if you can see that I'm using, I write here is D. Okay, suppose usually we use dy dx, d, is it? D. But now you can see that they have a curly D here. So this is how actually if we involve with PDE. Okay, so if for ODE, we will write D. But for PDE, this is how we write the D. It will be like something like curly lah, curly D. Okay, so but the same meaning lah, is a differentiation. Okay. Okay, I write first. Oh sorry, this one will be dx. Okay, class dx plus e du dy and plus fu equal to 0. Okay class, so I read it again here. This is okay, a d square u dx square plus b d square u over dx dy plus c d square u over dy square plus d du dx plus e du dy plus fu. So all a, b, c, d, e, f actually is a scalars. I mean it's just a number. Okay, it's just a number lah, 1 until 100. I mean any number. Okay, it can be any number, can be positive and negative. So it's just a scalars. So and the notation here, a, b, c here is already fixed lah. For a here is a scalar for d square d square u dx square, and b is for d square u dx dy, and c is for and so on. So you this is the general form of the second order PDE. Okay, so now what's mean by classification here class? So they have three. We can classify it to 3 classes. So the first one we have the elliptic. Okay, the name of this class is elliptic. The second one is parabolic, and the third one is the hyperbolic. Okay, so elliptic. Okay, when we want to when we say that is elliptic, okay, or how, okay, or I mean how we want to identify whether this equation, okay, is elliptic, parabolic, or hyperbolic. Okay, it's said to be elliptic if your b square minus 4ac is less than 0. Okay, I will just write it first. Okay, and then for parabolic is b square minus 4ac equal to 0, and for hyperbolic is when b square minus 4ac greater than 0. So class, you can see that this is the fixed formula. B square minus 4ac is already fixed, but just the difference here is on the sign, which is the equality, whether it's a less than, equal, or greater than 0. So okay, you can see that they have only 3 alphabet or 3 scalars that we need to consider, which is a, b, c, only 3. So if you get the equation, so this is a general equation, but if you get the equation, we just want to know the variable or the values for each a, b, c only. So d, e, f you just ignore. Okay, so what I mean here, what I want to say here, you just focus on the equation of d square u dx square, d square u dx dy, and d square u dy dx. I mean you just need to find out the value of in front of it. What's the value that in front of each term? So that will be your a, b, c. So the rest d, e, f, so you just ignore because we doesn't want that one. We just want to have a, b, c. After you get all a, b, c, just substitute back into this equation. Then you check whether your value that you get after that is less than, equal, or greater than. If you get less than, so that equation is classified as a elliptic. If you get the equation equal to 0, the equation is classified as a parabolic. And if you get a greater than 0, the equation classified as a hyperbolic. So I give you an example here. So let's say A, you have d square u dy square plus du dx equal to 0. So this is your equation, and what the first thing you need to do is you compare with the general equation just now. You identify what is your A, or where or which term that consists of A, B, C. So for this one, you have d square u dy square. So suppose in front of here, what is the scalar? It will be b, is it? C. It will be C. Okay, this is C is for d square u dy square. So in front here is C, and how about this one? This one is what? D. So we don't want to have D. I mean, that's mean what I want to say here. You just ignore lah this term. Okay. So your C, what's the value for C? Okay, compare class, compare. What I mean by compare here, in front here you know this is C. Okay, but in front here is nothing, right? But it's not nothing, it's equal to 1. Kalau dia nothing ataupun kosong, maksudnya dia tak ada lah benda ni. Okay, maksudnya macam ni, d square u dy square in front of it, what's the value if in front of it? It is 1. Okay, it is 1. Okay, bukan kosong, bukan. Kalau kosong tu, kalau kosong darab ni, maksudnya kosong semua ni, tak ada pun wujud benda ni. Okay, there will be 1 in front of it. Okay, 1. So your C is equal to 1. How about your A and B? Okay, because you need to have all these three, then baru you boleh proceed to this equation. So how about your A and B? A is a coefficient for what just now? A is a coefficient for d square u dx square. So is it exist any d square u dx square in this equation? Ada tak? Ada tak? Wujud tak d square u over dx square here? Nothing. I mean they have no existence of a d square u dx square. So that's mean your A is 0. Okay, because they have no it's not exist in your equation here. Same goes to B, because they have no d square u d over dx dy in your equation here. So that will be your B also equal to 0. So now substitute into this equation. So B square, so 0 minus 4. What is your A? Your A is 0. What is your C? 1. So negative 4 times 0 times 1, 0 lah. Okay, kosong kat sini, ada kosong sini, so everything is 0. So when it's equal to 0, therefore this is a parabolic. Okay, so this is a parabolic. So the PDE, this equation is a parabolic. Okay, so this is how we find it. Okay, so I give you another one example. B, d square u dx square plus d square u over dy square over equal to 0. Okay, so what is your A, what is your B, what is your C? Your A here is 1. What is your B? 0. Your C is 1. Okay, why B 0? Because they have no term of dx dy in this equation. Tak ada. So when it's not exist this term, that's mean your B is 0. So just substitute again into this equation. 0 minus 4, 1, 1. Therefore you get negative 1, and negative 1 is less than 0. So therefore this is an elliptic. Okay, next, d square u dx square plus 3 d square u dx dy plus d square u dy square equal to 0. Okay class, so what is your A, what is your B, what is your C? So your A here is 1, your B here is 3, and your C here is 1. So B square minus 4AC equal to 9 minus 4, 1, 1. So therefore is equal to 5, and 5 is greater than 0. It will be hyperbolic. Okay, so this is a hyperbolic. Okay, so I give you another example. D square u dx square ABCD. Okay, plus d square u dy square equal to 0. Tak nak lah, yang ni tadi dah ada kan? Belum. Okay, d square u dx square plus, okay, so what is your A, what is your B, what is your C? Your A here is 1, what is your B? 0, and your C here is 1. Dah ada lah tadi. So B square minus 4AC, 0 minus 4, 1, 1, negative 4, less than 0. Okay, dah ada elliptic. So this is elliptic. Next example, okay, d square u dx square, and in front here is k, constant k, equal to du dt. Okay class, so first thing first, actually, I suggest you to move this to this side first. Anything that you have at the right hand side that consists of you, okay, okay, you put it on the left hand side. So it will be this equation lah. Alright. Okay, next. What is your A? What is your B? What is your C? Okay, class. So this is supposed to be the first term, which is this is your A. So just write it. Your A is K. Just write. Even though you see that they have no numbers in front of it, but we don't want to know. We want to bother what's the value. We just want to take the value, what we call the scalar that exists there. For example, here is K, so just take it K. Just take it. Okay? So K also is number lah. I mean, for this equation, maybe K later on we substitute number. Okay? But for now, you just take it K. And B, they have nothing, they have no term that consists of d square u over ds dy, so it will be 0. And how about C? C also 0, because they have no existence of d square u dy square. So this one just ignore, okay? Because we don't want to have any D, E, F, okay? We just want to have A, B, C. So B square minus 4AC. So B square minus 4 is 0, 4KC. So this one equal to 0. So it will be the betul lah, parabolic. Okay. Okay, next, the last one. D square u dx square, and in front here they have a square equal to d square u dt square. Okay, so as I mentioned just now, we move this one to the left hand side first, and this equation equate to 0. So then what is your A? What is your B? What is your C? Your A here is A square. So just take it. Okay, class, just take it. Even though this is alphabet A square, it's not a number, but just take it. Okay, so B is 0. How about your C? Your C is -1, class. -1. So that's why, that's the important part. Why you need to move this one to this side first. Even, let's say, imagine that you just leave it like this. I confident that maybe some of you will write C is equal to 1. I'm pretty sure that some of you will write C equal to 1 if you didn't move this term to this side. Okay, because you see that they have positive. But when you change it, it will be negative, class. Okay, kenapa kena tukar sama, kenapa kena move? Why we need to move? Because the general equation all here is on the left hand side, and this equation is equal to 0. So everything must be moved to the left hand side first, then baru you cari A, B, C. So that's be your C is -1. Okay, so B square minus 4AC equal to 0 minus 4. Your A just now is A square, and your C is -1. So negative times with negative, so positive. So 4A square. And okay, how we can know that it is elliptic, parabolic, or hyper? Because they have no fixed number, is it here? So what we can know, what we know that A square or any number that power 2 is always positive. Okay, class, any number with a power 2 is always positive. Let's say I let our A is -1. So A square will be +1, kan? Any number. So any number will be lead to positive. So therefore, 4A square is always greater than 0. There it will be hyperbolic. Okay, it will be hyperbolic. Alright. Okay. Okay, class. So I think I will stop it now. So I will continue with another topics in the next video. So in this video I just explained on how to classify the PDE. Okay. Alright.